Yeah, it is 2I minus 2k.
2I minus 2k, right? Yeah. Okay. So yeah, so there is the solution of this. I have tried by myself once. Okay, so the next question is, yeah, so the velocity field of a fluid flow is given by Vx equals to 4xy, Vy equals to 2x square minus y square. Which of the following are correct? So field is one dimensional, the flow is incompressible, the flow is irrotational, and acceleration experienced by fluid particles at some point is 0. So first of all, the first option is not correct, right? So this is not a one dimensional field. You have given a two component of velocity, which is Vx and Vy. So this should not be one dimensional, but you have to calculate for the other three, whether this is incompressible, whether this is irrotational, and you have to calculate the acceleration experienced by fluid particles. Okay, so how can you do the incompressible thing and irrotational thing? First of all, what is how can you calculate or check whether this is irrotational or not?
We calculate the vorticity of the fluid. So that will tell us whether it's irrotational or not. If it is irrotational, it has to be incompressible according to the lectures.
Okay, so you were telling that if it is curl of V is 0, then it will be irrotational, right?
Yes, yes.
Yeah. So for 3, you have to check curl of V has to be 0. Okay. And the other, the flow is incompressible. How can you calculate that? You know the mass
Take the
can
divergence of
take the
velocity field.
divergence of velocity field. So
Divergence. No,
how this
velocity field.
how this is related with the incompressible condition? Can you tell me?
See, the logic that I am
If
using
the
here is
divergence goes to zero,
That's fine, but how this is related to incompressibility? Firstly, incompressibility is basically the constant of, I mean, the density has to be conserved, right? So, how this is giving you the density conservation? Are you guys familiar with the mass continuity equation?
yes.
So,
yes.
what it tells? It tells something like, sorry, del rho, not a vector obviously, del rho, sorry, क्या हो गया? Hello, am I audible?
Yes.
Okay, somehow the system is not working properly. Just a second. Yeah. So, so we have. It's already there. Just a second. So del rho del t plus divergence of rho p is equals to 0, right? This is the mass continuity equation. Okay, now what happens is you have del rho del t plus you have two terms, right? Gradient of rho dot v plus rho gradient of v equals to 0, correct? Now have you familiar with the material derivative? I mean, there is a
Yes.
Eulerian frame, there is a Lagrangian frame, right? Yeah. So these two, the first two, system is not working. Am I audible?
Yes. Yes. You are.
Okay, so something is happening. So this is del rho del t plus this. This will give you d rho dt, right? This is the derivative of the density in the Lagrangian frame. So you have this equation, divergence of v, that is going to be 0. Now d rho dt, that is the change of the density looking by the Lagrangian observer. So someone is sitting on the fluid, he is flowing with the fluid and he is measuring the change in the density. Now in case of incompressible, this d rho dt is going to be 0. Okay, now if it is 0, then rho divergence of v, that also has to be 0, right? So divergence of v will be 0 in this case due to this reason. Okay, got it? Basically this is d rho dt has to be 0, and since this is the mass conservation equation which has to be satisfied, so due to that the divergence of v has to be 0 to be incompressible. Okay, okay.
Yes. Understood.
Yeah. So now I think you can calculate this divergence of v and curl of v by yourself. And the last thing is the acceleration experienced by fluid particles. Again, you need to calculate what is the,
Yes, sir. Yes.
in case of acceleration, you need to also calculate dv dt, not del v del t. Okay. Why this is so? So we are doing everything in the Lagrangian frame. Okay, otherwise what happens is there is two things. So the change in the velocity can be due to two things here. So there is del v del t, okay, that is also a part, and another part is v dot grad v, right? There is two part. So I have to calculate this dv dt. Okay, so I have to take this del v del t also, v dot grad v also. Okay, so I have to calculate this both things to find out the acceleration experienced by fluid particles. Okay, so I think you can do everything. First of all, check for curl of v and divergence of v and let me know what is the answer.
See, for the fourth option, can we directly tell from Vx and Vy that it will be true? Because Vx and Vy, both of them are time independent from the expression.
See, what I am telling, that this is basically due to, if you are doing the del v del t, then you are getting 0. Okay, but there is a change in the velocity as the flow is moving, right? Because the velocity field is depending upon x also, x, y, this spatial coordinates also, right? And you have to calculate this dv/dt. So del v del t is 0 obviously, but there is another term, this v dot grad v, and here the grad is basically del x, del y, those things are there. That does not need any t dependence, that need only the spatial dependence. Now if this is 0 also, then you can tell that okay, the acceleration is 0. Otherwise there is some acceleration due to this spatial change in the velocity. Okay,
Okay. Mhm.
so calculate it and tell me. Sumit, are you trying?
Yes, yes, I'm trying this.
Okay. Prabes, are you trying? Sachin, Prabes, Dhriti, Amit.
See, I'm looking at divergence as 0. I am again making a mistake in finding the curl maybe. So that is where I'm stuck.
Okay, so divergence is 0, right?
Yes.
So this is incompressible. Now we have to calculate the curl. Do that.
Yes. I see they are saying the curl is also 0. Somewhere I am not getting it. So let me check.
Yeah,
Might be
check.
making a mistake.
Okay, both is 0, curl and divergence. Okay. And the last one. In the last one, the del v del t will be 0, but you have to calculate the v dot grad v. So that will have two components, right? So you have vx del x of v, and then that v vector has two components, vxi plus vyj. So you have to calculate the del x of vx also, del x of vy also. So that will give you the x component. Sorry, that will give you one component. The other thing is, from v dot grad you will get vy del y also. That will also operate on the v vector. That will also give you I plus j component. Okay, and after that you have to just extract out the components with I cap and j cap, and then you can tell that this is ax and this is ay, which are the x and y component of acceleration. Okay. Last option is wrong. I am getting acceleration. So Sachin, can you try once whether you can show your copy to us? Just open your video camera and show the copy what you have done. Okay, sorry. So for do that, okay, I don't need to stop presenting, I think. Is it? Sachin? Yeah, so you have shared something. Is it visible to all of you?
I'm getting that as 0.
You are getting 0. I think it will not be 0. Some non-zero quantity will be there. Let's look for the Sachin's calculation. Okay, so you have done this. Okay, fine. It's your process is, I think, correct. Okay, let me show the slide now. Okay, so I think it's visible to all of you. So these are those things. The second thing is you have del v del t is 0. So you have two components. One is the Vx del v del x and Vy del v del y. So what you will find is you have to calculate the Vx del Vx del y and Vy del Vx del y. You will get this to be 0, the x component, but the y component will not be 0. So as a whole, the acceleration will not be 0. Just look at the process I have done, that is v dot grad v. So you have two components, right? So you have Vx del del x, which is acting upon v, and Vy del del y, which is acting upon v. Then basically this v vector will have two components, right? One is Vx I cap plus Vy j cap. Then you have the Ax component, which is dvx dt. Okay, so now from v vector you are taking the Vx and you have calculated the del Vx del x plus Vy del Vx del y, and then you have going to calculation, and finally what you have to do is put the x and y value. Similarly in Vy component also you have to calculate the del Vy del x del Vy del y. Okay, that is going to give you 0. Sorry, not 0, this one is 0. So finally this will not be a 0. So this is the process. Okay, now the calculation is up to you, I think. Yeah, so Sachin, are you getting this kind of answer here also? Hello Sachin. Yes, so okay, finally we have the last question here. So okay, is it visible to all of you now?
Yes, visible to me.
Yeah. So
Yes.
consider the velocity distribution function of a Maxwellian gas, which is, let's say, F. In order to compute the pressure of the gas, one needs to know, this is the question, right? So first of all, tell me how pressure can be calculated?
Using the kinetic theory, we can get the pressure. P is equal to N kBT.
In kBT. Okay. So kb is a constant. N is the density, number density, and T is the temperature, right? So how to get number density and temperature if we know the distribution function of velocity?
You integrate over all the space and velocity to get the number density.
Okay.
Integrate F,
Okay.
d cube x into d cube v.
Okay.
So that is the zeroth moment of F.
Mm-hmm.
And for temperature, you calculate the mean squared velocity and then you equate the two. I mean,
Mm-hmm. Okay.
equate what is it? The v square with the energy half mv square, right? So you equate the half mv square is equal to 3 by 2 kBT. So from there you get the temperature.
Okay. So basically what he's saying is, let's say if we need to calculate the density, that is f. Now f is a function of x as well as v, right?
Why? V is
Yeah. So x is for xyz, v is for vx, vy, vz. Now when
yes,
we are going to have the density only, then we don't need to integrate our dx, right? You just have to integrate our v, correct?
dv, yes.
Yeah. So it will give you the n. Now this has basically a v0, right? That is 1 multiplied with it. So this is zeroth moment, correct?
Yes.
Zeroth moment. And the second thing is, you have a temperature to find out. So what a temperature comes from the kinetic energy, right? So you have half mv square and f x v dv, correct? Now this way, you see, this is a second moment. If it is 0, this is second. So this basically gives you a final answer as v is proportional to some root over t, correct? So from there you can get the temperature. So you need the 0th moment of f for calculation of density, and you need the second moment of velocity for calculation of temperature. So if you know first and second moment, sorry, 0th and second moment, then you can find out the pressure as P is N K P. Okay. So this is the answer. Okay. Any problem?
No.
Okay. So I have this much today. I hope things are clear to all of you. There are some technical glitches during classes. I don't know why, how I can. Aryan Vake. So classes over for today.
So will you be sharing these slides on our
Yes,
mail?
slides will be shared. That's fine. But I think there is some issue with the recording of the entire lecture. So I don't know how should I share it in YouTube. That's a problem. But yeah, I will share the slides. Lecture will also be shared, but the entire duration might not be there because somehow the recording is not correct or perfect. Okay, I will see. But definitely the slides will be there. So that's not a problem. Okay, so I hope things are little clear and will help you to solve the assignment. I don't know whether any question is matching with any assignment question also, because I have to make the questions by myself right now. So I looked at the contents in the lectures, and depending upon that I have prepared some questions. I think it will be helpful for all of you to solve the assignments. So yeah, if there is no more questions and no more queries from your side, we can meet on next Saturday for discussing some other problems regarding the lectures in second week. Yeah. Any
Okay, thank
problem?
you.
No, thank you very much.
Okay, okay. Thanks to all of you also for attending. I hope it will be helpful for all of you. Okay, so thank you very much. Yeah, thanks.